Our lesson today is on turning points and their nature. So to help me explain what turning point is, we shall consider a curve. All right, so we have this curve. Y is equal to f of x. Okay, now on this, if you take this curve as a normal, let's say a road that you are traveling on, when you get to P, you would curve, right? And then when you get to Q, you will curve. When you get to R, you will curve. Then you continue the journey. Okay. So all the points that you curve, we call it the turning point. Okay, the turning point mathematically. Well, in mathematics, it's not just about you curving or you descending and you climbing. No, it's about the change in the gradient. Okay, the change in the gradient. So a turning point is defined as a condition or a situation in which the gradient changes from positive to negative or from negative to positive. Okay, all right. So if you take a look at this curve, you will see that on the left side of P, the gradient is decreasing. Then on the right side of P, the gradient is increasing. So that is what makes P a turning point. And the same thing can be said for Q. On the left side of Q, the gradient is increasing. On the right side of Q, the gradient is decreasing. So since there's a change in gradient, that's from positive to negative, we say that Q is also a turning point. And the same is true for R. All right. Now, when you have a curve like this, we have the heights and then the lows. Okay. So in mathematics, we call it the absolute maximum and then the absolute minimum. Okay, so if you look at this curve, you could say that the highest point on the curve would be around this point. Okay, I don't think it's that point, they look almost the same, but I think it's here. Okay, so that's the absolute maximum, and then the lowest point on this curve will be point R. Okay, so that is called the absolute minimum. Right, so but between the absolute maximum and then the absolute minimum, there are other minimums and other maximums. Okay, so we call them the local minimum and then the local maximum. Okay, so for example, this is higher than these two, right? So we call it the local what maximum, and then this is lower than this. Okay, and this is also lower than that. So these 2 points, P and R, could be called local minimum. Okay, so that is what we should keep in mind. Now at the turning point, we say that dy dx equals 0. It means that the change in y as a result of the change in x will be 0, and it is true. Why? Because if you should rule a line through P, horizontal line through P, okay, and you have to find the gradient of a horizontal line, the answer is 0. That is why we say the change in y as a result of the change in x is what? Is 0. Okay, so at the turning point, dy dx equals 0. You hear this in school. People normally say it at the turning point, dy dx is 0. Why? It's because of this reason. Okay, so let's take a question and then solve and see how we will apply these new ideas. So we have a polynomial, a curve like this, y equals s cubed plus s squared minus 16x minus 16. Okay, so what are we supposed to do? We are supposed to find dy dx, and then we would find the coordinate of the turning point, we find the second derivative, and then we use to determine the nature of the point. Okay, so when we are determining the nature, then we want to talk about, is it a local maximum or local minimum? Okay, because we know there will be a turning point, but what is it? And what is the rule to help us determine whether it is a minimum or a maximum without you drawing the curve? Okay, you don't have to draw it, but it would be nice to draw, because when you draw, it gives you a clearer picture. But we have a way to go about it without, drawing and still get the answers. So that's what I would do. Okay, so the first part said we should find dy dx. So we will differentiate this with respect to x. So we will have 3x squared. Okay, so the 3 multiplies here. Then you subtract 1 from the power. All right, so that's how differentiation works. If you haven't watched my introductory video to differentiation at this point, I'll urge you to pause it and go and watch it so that you understand how we differentiate a function or a curve like this. Okay, so this is the differentiation that they wanted us to get. Right, let's move on to the second part. What part B says we should do what? Find the coordinate of the turning point. Well, at the turning point, we saw from our curve that dy dx equals 0, right? So what we have to do is that this gradient function that we have achieved, we are going to set it to 0. Why? Because we said at the turning point, dy dx equals 0. So that's what we are going to do. Right, so we will have set it to 0. This is a quadratic that we are going to solve. Right, so I've repeated it for us. So when you solve this quadratic by means of factorization, or you might want to use the quadratic formula, or you might want to use completing the squares, it's fine. Any approach that gives you the roots to this quadratic function is acceptable in mathematics. Right, so x equals 2 and then x equals negative 8 over 3. So now these are the point at which the curve turns, okay? So on the x-axis at point 2, the curve will turn, and then at negative 8 on 3, the curve will turn. But remember that we are looking for coordinates of the turning point. So given the x value, we must look for the y value because every coordinate is x and y, okay? So we will put x equals 2 into the curve itself, that cubic curve, and then we will determine the y value. Then we also put this negative x value into that same curve to determine its corresponding y value. So let's do that. So when x equals 2, y will give us negative 36, okay? And then we have the point. So this is one of the turning points, okay? 2, negative 36. Right, so when x equals negative 8 over 3, what will y be? So y will be 400 over 7, okay? Of course, you might want to convert it into mixed number, that's fine, or mixed fraction, however you call it, is acceptable. But I want to work with this. Okay, so I will write my coordinates as this. So these are the two turning points that I'm looking for, all right? Now part C says we should find what? The second derivative, okay? So when you are asked to find the second derivative, it means that first do your first differential or the first derivative, then you differentiate it again. Okay, so this was our first differential that we got. Now they want us to find d square y dx squared. So it means the second derivative. So we are going to differentiate our gradient function. So when we differentiate this gradient function, we get 6x plus 2. Okay, the differential of a constant is 0. So the 16, negative 16 goes away. Now we are to use the d process, which we determine the nature of the turning point. So this is what we do. You have the second derivative, but remember that the turning point itself came with some x values. So those two x values, that's x equals 2 and then x equals negative 8 on 3, you put them into this function to get a value. Then there is a law that we are going to apply right now to see whether it is a maximum or a minimum, all right? So when x equals 2, the second derivative is giving us 14. So 14 is positive, okay? It's positive. So when it is positive, we say that the point is a minimum point, okay? That turning point is minimum. Put this one in mind. Whenever the second derivative is positive, the point in question, that turning point, is minimum, okay? So now let's go and substitute x equals negative 8 on 3 into the second differential. Right, so when we do that, we have negative 14. Okay, so this is the second rule. Whenever the second derivative is negative, derivative is negative, we say that that turning point is maximum. Okay, that turning point is maximum. Right, so we can say that this, okay, is the maximum turning point, wherever the other one was the minimum turning point. Okay, remember these turning points, we found them, but we needed to determine the nature. That means we needed to know whether it is a maximum or a minimum. All right, so whenever you are to determine the nature, kindly differentiate your already differential. Okay, again, so that is the second differential. All right, then you use the x values from your turning point to determine whether it's a minimum or a maximum. A maximum will be negative and then a minimum will be positive.